Okay, can everyone start regulating the screen? Okay, so everyone, welcome back to another session on learning with business programming. In this today's session, I'm showing you the very basics of R programming, and that's for the first part. And the second part, I'm going to tell you a little bit about software engineering project management for business students. Although this topic is a little bit about IT, but I think that is very useful for business students like you guys. So let's get started. So at first, I'll talk about R. R is an interpreted programming language. Allows you to carry out modular programming with the help of functions. It is widely used to analyze statistical information of a graphical representation. And a little bit about R is that it was appeared in 1993 and wrote by these guys from New Zealand, and the name R start from the first word of these guys' name. So R allows you to iterate programming procedures in languages like C, C++, Python, .NET, Java, or something. Today, R is widely used in the field of data science by data analysts, researchers, and statisticians furthermore. In fact, R is one of the most commonly used programming languages in the data industry, according to the user survey. And as of this year, it ranked 16 in the TLB Index, which is a measure of programming language popularity, and even reached the top 10 back in 2020. And to use R program, you can install R on your local machine. You use the online environment. About installing on your machine, R has binaries for all operating systems like Windows, Mac OS, and Linux. So you can use any of these OS for your R. And then visit this site and download the binary for your operating system and follow the instructions on the installation wizard. But you should know that installing R is not enough alone because R does not provide with a graphical user interface platform. Usually, that means you have to separate an IDE, integrated development environment, to be installed. It actually, unfortunately, doesn't help with Field Central. Usually, there are many things to do like VS Code or IntelliJ or something, but usually the RStudio is the most popular. You can follow the steps here to install on your machine. You will use online compiler environment. You have to do the hassle of installing if you want to, if you're lazy. Usually you use these or these, but however, it will not be suitable for software engineering. So now, I've already mentioned about installing R in RStudio. Now, let's try running the first program. So usually when it comes to learning programming, usually the most simplest way is to do a hello world program. A hello world program is a simple program that simply brings a hello world message on the screen. It's generally used to introduce a new language to learners. Here's the simplest. See this here? This one? You can see a little bit about R. Okay, here's the R user interface, but it doesn't have any programming functions here. So you have to use RStudio. RStudio is an environment that you can use to type code. You can see this is where we're working. And there's something different I want to tell you. Usually when it comes to running here, you have to use the word print to run. But however, there's something strange you can see. It's because that we're in the object-oriented programming condition. You know that on the previous week, I only tell you about object-oriented programming. So in the object-oriented programming, the word print is useless and it will not be able to run. So have to replace the print with the word cat. And it will run. Yes, it's because this is an object-based program now. So it's not necessary that we have to use the word cat. But however, if you are not doing an OOP program, using print is good enough. You should know that every output in R is preceded by a number in square brackets. You can see here's the data table, and and the functions have been here. It's actually a lab from the previous session last week about OP. And this number means that the display below is the nth element printed. So Next thing I want to do is I want to talk about a bit about commands. Commands are portions of computer program that are used to describe a piece of code. For example, you can see on this here, or here. Yeah. In general, all programming languages have commands and same are single line and multi-line. Usually for single line, just have to use this or this. However, all there's not any syntax in multi-line commands. However, the only way to do that is to use several multi-line commands and merge to one. For example, like this one. The purpose of commands is to document a piece of code, increases readability, provide metadata of the code. Metadata means the data of the data, and should be used by programmers to ignore a piece of code in testing. And it can be used to write a pseudocode. A pseudocode is like the base, the tree of code. And from that, you can change it into computer source code. Now, we just saw something that's very important. We're talking about the syntax already. Now we're talking about variables and constants. You see in the computer programming, a variable is a name memory location where data is stored. Whether it's not related to memory allocation or dynamic management here. For example, X. You can see that X, Y here, and you can tap the Y. See, here's a variable, 666. That means that Y variable is stored, we get that word as the output. Please note that there are some rules when you declare a variable. It's called naming conventions. First, that you can create a variable name using letters, digits, periods, and underscores. You can start with a letter or period, but not digits, alright? And please know that if a variable name starts with a dot, you can follow it with a digit. For example, if your variable is this, you can do this, but not this. And it's a case-sensitive programming. This means that age and age are different variables, even if they have the same quality or number. And depending on the type of data I want to store, variable to be divided into types like Boolean. A Boolean means that it can be either true or false. True is yes, and false means no. I shall no. For example, you can see this code. Is a see the value is true, and if the class is a logical value, it's a logical class. The next thing is the integer variable. It stores numeric data without decimal values. For example, and run it, we can see it returns an integer. It also solves floating points as well. For example, it's a numeric value. In fact, it's a floating point. Floating means that it has a dot and some numbers after the dot. Next is the character variable. That means store a single character data. For example, B. And then you change it. Yes, it means it's a character. And then string. Remember that we are in the OOP way, so we have to use the word cat, alright? So you can see this is the character of, but the difference that is the word, so word, and this is a string. But actually, they're in the same class of characters. And in fact, in R programming, you can change the value of variables. Depending on the conditions of function passed to the program, you can change the value of it. For example, you can see here, then you click that. It will modify the message from what was Almighty to COST 2092. You can see. And also there's some R constants. Constants that don't entirely values that need to be changed anywhere through the code. But you declare it using these one. And there are various types of constants like numeric, integer, complex, logical, and string, as I mentioned. There are also some possibilities, which are this one. We can see this is the example. You can see, we like this is a constant about integer. Well, the same goes for hexadecimal, exponential. It will generate the same result you can see here. You can copy the code and modify, and don't forget to change the word print to the word cat if you're learning an OOP. About special R constants, it usually use the word no to declare an empty or object. Or you can use a in or if here to represent positive and negative infinity, or not a number. Will undefined numerical value. There are also some built-in constants as well. For example, you can print now the letters. This is a built-in constant. You can see iterate this one in uppercase, or you can run in lowercase here, and the same goes for the rest. Now we're going to talk about the basic data types of R. The basic data types I've already mentioned above, including logical, numeric, integer, character, complex, and raw. Most of them I've already mentioned on the first part. Here I only managed to introduce some special things. For example, like complex value. Here. Complex value that mean that the value of a complex number with the word I on the number. Or you run it, it returns the complex class, and you can see, and then the raw data type. Raw that mean that special value is raw bytes. You can use the methods to convert character into raw data type and vice versa. Don't forget to change it into cat because we are in the object-oriented programming condition. If you're not in the object-oriented programming condition, then print the word print is already okay. You can see here's the result, here's the raw variable. You can see. And in this program, we have used the char to raw and via raw output. You can see on here. Then we have used the print output. You know already the print output, I already mentioned above. But however, there are some others we can use. For example, the paste 0, the sprint f, and it's used to print format string. So let's try it. See, you can see here's the result. You can see the format string here. And you can also use the cat function. The cat, however, is used with the basic types like this, and this. However, the cat function is like a limited version of the print. Because at the end of the day, we have to use the print one to be more popular since I'm using the OOP condition. So usually I have to use the word cat. But I recommend you use the word print if you're not planning to do an OOP program, all right? And finally, we'll talk about numbers. Numbers are split up into three different categories, which are numeric, integer, and complex, like I mentioned above. And those things I've already mentioned on the first part, so I will not explain it again. Now, when it comes to about doing a program, the most important thing is what it's about the conditionals, the Boolean expression. The Boolean expression I've already explained are true or false. But imagine if you want to compare a number between if it's larger, it's smaller than the others, then you may need to use things like if else. So what is an if else? This is a statement that allows us to create a decision-making program. A decision-making program that runs one block of code on the decision and another of code under different conditions. For example, imagine an election. If the participant age is greater than 18, allow him or her to vote. But if it's not greater than 18, then it's not allowed. Usually, the syntax of if statement is that if this, the body here, it returns either true or false. If it's true, then the body of the if statement is executed. If it's false, then it's skipped. For example, yes, the number is positive. That means that the word if here has been executed. We can also use the if else here. For example, imagine of this. I can say I forgot to change it into print because we're in the our condition. So remember, if you're in our condition, you need to use the word cats. Yeah. If the age is 15, then it returns you can't vote. However, let's try change it. If I change it to like 26, then the result is you're eligible to vote. So that's a little bit about the if else. Usually there's a more positive if else if here, but I won't explain it because I'll let you guys to explain on the go because this is just a little basics. And there's also the while loop. The while loop is the basic conditions of calculate sum. And is the while loop here? Just know that this is cat. Then here's the return of 1, 2, 3, 4, 5, 6 there. So it's 55, you can see. So that's what the while loop means. The for loop is the same. There's also a break or a break, that means which ends the loop, but I won't explain it here. And there's also some other about their structure, visualization, manipulation, but due to limited time, I will not explain and them. It's your responsibility to understand them. On the side, you can see. Now, this is the end of the first part about R programming. On the next part, we're going to discuss a little bit something about project management. So as you can see, when you do an assignment in your course, usually one of them will require you to do a big project with your teammates, about 3, 4, 5 teammates, depending on the course. So in addition to all the technical knowledge that you can accumulate during your journey and course, you need to also a little bit about project management. So in this part, I'm gonna introduce a little bit about software engineering project management. It's not installed data engineering project management because this is doing the new software. So what is software data engineering project management? We call it SEPM or DEPM. So it refers to a defined system of processes and practice design to have accomplished software and data objectives. For example, like if you want to make an e-commerce full stack web application, what you do? You have to think of the UI, the data, the front end, the back end, and the technology you want to use. You need to also think of doing stuff like manuals, tech report, or product demo or something. And usually it's best if you can apply it in teams. You can basically use methodologies to deliver a new product and also to update existing one. Usually, other tasks can be usually useful for this was like operation management, the driven development, triple D, performance system development, and software documentation management. In fact, almost agencies can benefit from the use of a project management platform that's specific to software development, which in most cases, additional project management plans should be one-sided because usually software data projects come with all kinds of new nuances like complex data or object-oriented programming technologies, and has an inherently complex lifecycle process. But the technology used to develop it is so dynamic that the process can really be applied the same from one product to the next. For example, the process of making an e-commerce web application can be applied to make OP products or even store management system. If a dedicated software engineering process, teams can deliver quality products to meet clients' needs in a timely manner while staying on budget. In fact, 60%, in fact, it's actually 70 to 80, if not all the projects, software users report that the platforms allow them to better estimate milestone and timeline for product delivery. They also encourage better communication across team members about tracking, reporting, software testing, and workflow automation tools. So you should know that software engineering project management is very important because, like someone used to say, if you don't have a plan, you are blind to fail. So you need to apply some management here. Now, in the first part, we already talked about development methodologies, so I'm going to explain more about it. You should know that successful projects are managed very well, and in order to do that efficiently, you must choose a software development methodology that will work best for the project at hand. All methodologies have different strengths and weaknesses, and it exists for different reasons. For this part, I'll only tell you the two most commonly used software development methodologies. The first is Agile. So what is Agile software development? And Agile is an interactive and incremental approach to software development. It emphasizes cooperation between the development team and customer flexibility and adaptability in the face of a change in requirements and delivery of working software in short iterations. And usually when it comes to Agile, you need to work in the word sprint. Sprint, that means that it has SPA, plan, design, develop, test, deploy, review, and launch. And then the process is repeated until the end of the software project. Usually, this methodology is used to minimize risks like bugs, errors, overruns, providing new functionality, and all methods to build a software iteration that contain many increments of the new functionality. For example, like if you have a e-commerce web application, first you do the customer function, then the seller, the shipper, the product, the order, blah, blah, blah. And there are many different forms of Agile development method, like Scrum, Kanban, Whistle, extreme programming, and future-driven development, or Triple D, as I mentioned in part 1. And another development method is that the waterfall method. The waterfall method is in fact the traditional way of making software that everyone used to do. You can see the waterfall for a traditional process of 6 steps. A rigid linear model consists of phases such as requirement, design, development, testing, deployment, and maintenance. RDDTDM. And it focuses on distinct goals. That means each phase will be 100% complete before the next phase can start. For example, if the design is not complete, then the implementation part cannot be begin. And there's usually no process for going back to modify the project or direction. So if this part, requirements and design are not done properly, they will affect the remaining part and the entire project in general. And in addition to Agile and Waterfall, there are various other project management methodologies that's currently available. For example, hybrid, which is a mix of this and this, or RAD, rapid application development. But, however, in the scope of this lesson, I won't mention about hybrid or RAD. You need to go to the internet and find it yourself. I only mention the basics. Now let's talk about teamwork and tools. A definition from Wikipedia is that a team is a group of individuals, to be human or robots, working together to achieve the goals. The goals include making multiple projects, writing reports, doing presentation, demo, and more. And usually when you work a team, there may be some issues that can hinder success to the project in past and in general of the project, such as unclear goals. That means that the team did not understand what to do or optimizing for different things. And if that happens, you can pause the work and conduct some meetings, like stand-up meeting, to establish the clear goals, and then structure the goal-setting framework, like KPIs, SMART, or following the sprint or agile that I already mentioned. And you have to regularly review and evaluate the process and establish goals. 2 is low engagement. Low engagement, that means that it has quiet team-wide ability. Team did not respond to your messages or something and decline the timeless support. That means people start to submit the work late, and all enthusiastic members become distant and minimally engaged. That means that they don't want to do the project anymore. Then you need to conduct one-on-one meetings with them to discuss their well-being and praise their accomplishment, and make sure to let them know how they contribute to the bigger goal. And you also have to share your customer lecture reports or stories that demonstrate the impact of your product. For example, like positive reviews or high mark or something. The third thing I want to mention is about the lack of trust. The lack of trust means that excessive high-five, maybe a fatigue, masking underlying issues. Usually, everyone is outcasting client in team meetings. You need to prioritize transparency in that case. You need to share the pain of working, like I have to work in other course, or I have to work in like that. And you also need to give and invite feedback when necessary. The fourth thing I want to implement is the information silos. I mean, it's not by duplicate effort, because team members are aware of each other work, and position making, because you can't assess everyone information, like you want to do the product first, but you forgot to do the order, and stubborn innovation. It can hurt your ability and cooperation and hurt the project in general. You need to utilize cooperation tools that make it easy to remember to share, find, access relevant knowledge, like making documents, calendars, as well by all members. And for that, I'm going to mention in the next part. You need to properly appreciate instances of cooperation led to positive outcomes, and then to address the underlying causes, mistrust or reputation. If that is found, then solve it using the instructions here. And finally, the worst thing, personally conflicts. Usually, when you're working as a team, everyone have their different ways. Usually, is some completely different, brutally different from you. Then it may lead to a case where everyone argues, debating, or tense, shouting between colleagues, and increased avoidance of meetings. That means that people want to boycott each other. Well, this is a very complex situation. You need to encourage teammates to resolve conflict directly with each other using diplomacy. And you need to listen to each person's perspective and brainstorm potential solutions. You can provide training in conflict resolution and effective communication for them, and you can create a safe environment where the team members can feel comfortable explaining concerns. But if all of these did not help, you can seek help from employee relations specialists or even your lecturer and tutor. Let me be able to help a little bit. Now, when I'm going to talk about the teamwork and some of the issues you may find, it's time to talk a little bit about teamwork tools. Usually, the teamwork tool, there are many things to say. The first is about the communication software, like MS Teams, just like I'm using, Zello, Messenger. Usually, you should be familiar with this. You should create the preferred chat group for your team. You should also consider to do other steps like Trello. Here is a dashboard-based tool that can manage your team sprint for your project. Or you can also use Jira. Jira is the same as Trello because both of them manage your user stories, sprints, functions, and all your software works. And you can also use MS Planner. MS Planner is what is new, but however, it's the same as Trello and Jira. Both of them, all three of them can be used to manage your function, your calendar, and the plans for your project. And about the tools to store your project, usually you have to use GitHub. So GitHub is a code repository that you can use to store your code. For example, you can see this one. Is you can see here's the codes, the assessment, you can locate it here. And also, for example, here's my personal repository. You can see here that I am storing the code in those folders. And for each folder, there's some piece of code that you can use. You can store the code here. And if Hub can function it, you can upload it into a repository. It's called commit. And when you want to code, then just copy to the local machine and use git bash to do git clone of this. But I won't mention it since it's very technical. If you plan to create a GitHub repository, you need to use a GitHub education path to help. It's called, actually, we have sold the GitHub student development path. It's for all MIT students and students of verified university. You have this path, you will have access to a lot of stuff, including that famous GitHub Copilot AI tool. And if you want to create a GitHub repository, you must make it private to prevent any instance of plagiarism. For example, the teams can go here and store your code and make it theirs, and only make it public after the project deadline. Usually, you need to start creating your Git repository as soon as the project is started, or as soon as you stop running. It depends on you. And for report writing, you can create a shareable document on Google Docs by allowing access to the teammates. Now, while you have everything ready, you may just start your project by brainstorming, discussing the specifications like, hey, we have to do this function, we have to do this function, we have to deploy the app or something. And you have to sketch your goals and plan. For example, like, hey, first we have to do this, second we have to do this, third we have to do this, so what? And then you're consulting your lecturer or tutor if needed. Usually for each week, while we are doing the project, you can do a stand-up meeting. For a stand-up meeting, it can be online or face-to-face. In here, each member will report about what they have done in the previous week, what they've done this week, and what roadblock they have. And then they can discuss to address mentioned challenge together. Here, everyone is expected to provide a solution to others' challenge to helping them clarify difficulties. And it can be done inside the class or outside the class based on your choice. Then, if the lecturer allows, you can share your project progress with the class and maybe invite to each other. We can discuss with other groups for issue or challenges. And finally, is a note about teamwork. When you work as a team, you need to follow the golden rules. For some of you who have a note, I'll explain a bit. The golden rule is one of the most important rules in ethics. In fact, people call this golden rule the laws of all laws. Most of the laws across the whole world are based on these golden rules. So the golden rules is a principle of treating others as you want to be treated by them. This is called the ethics of reciprocity. That means you reciprocate to others about how you want them to treat you, not necessarily how they actually treat you. For example, me doing this A job, and then the other must do the A job. And the other rule is also called the others rule. You have to listen to understand opinion is the key solutions. and to be humble, friendly, and respectful to others as well. Remember that we have to reach the same goal, at least in this course. So we have to have a team. If it can, then you can seek advice from your lecturer until they need it. So that's all I want to say about the software engineering project management. So remember, when you work on our software, then you need to use the tools efficiently, prepare your code, understand the specifications, and don't forget to follow the golden rules. So this is the end of the section. For any more information, you can contact me using my SID. So good day, everyone. Have a nice day.